Okay, let's press forward with subclasses and subtyping. As you'll recall, every time you make a class, you create a new data type that can then be used for holding variables, for creating variables to hold references to that class. Classes define types. Well, subclasses define subtypes. What's interesting is that if an object is a subclass of another class, you can use those objects and variables where the supertype is the type that's declared. Let's make this a little more concrete. So this is to give us the example of substitution. Here we have an inheritance hierarchy. The superclass is vehicle, and the subtypes are car and bicycle. So a car is a vehicle, and a bicycle is a vehicle, and then also a vehicle is a vehicle. So we can declare a variable v1 and instantiate a new vehicle object. And so v1 would be storing an object of this type. We can make a variable of type vehicle and call it v2, and we can put a car object inside of it because a car is a vehicle. And then we could make a third variable v3 of type vehicle, and we could put a bicycle object inside of that third variable. You can always assign subclass objects to superclass variables. So how does this work inside of our code? This allows us to avoid duplication in our newsfeed. Let's go to the source code. This is a better look then. So let's go to our newsfeed. And I can make this a little bit larger. And instead of having two array lists, one of message post and one of photo post, we now just have an array list of post. When we go to add a post, we can add variables of type post to that array list. And in our show method, for every object of type post, which we will call post, in the array list of posts, tell that object to display itself. Well, that's pretty nifty. Let's see it in practice. I have my newsfeed object. Let me make a new message post. Demo message. This is a message post. And I'm just going to take away that breakpoint and continue, and close my debugger. My message post exists. I will make a new photo post. Author, demo, photo post. File name. This is a photo post object, which is also a post. Okay. Newsfeed add post requires a post variable. But I can tell it to put in a message post object, and it will accept it, because a message post is a post. Newsfeed add post, put in a photo post variable, and it will accept it because a photo post is a post. If I look at my newsfeed object, there is an array list of posts, and there are two elements in there. And that first element is a message post, and that second element is a photo post because it can hold both types of objects. And so when our news feed is told to show posts, we'll get back to this problem. We'll get back to this problem in a little bit, but it does go through and is able to run the display method for both the message post and the photo post. Okay. So inheritance is making this object easier to write. We see it in the add method, we see it in the show method because of subtyping. Okay. We used to have to worry about add message post and add photo post as different methods because it was taking a different data type. By using the superclass, now we can put either one in there, and it consolidates the process of adding to that array list. So the thing to keep in mind is that the subclass objects, as I just demonstrated, can be used as the actual parameters to pass into the variable, into the parameter, the formal parameter that is expecting the data type to be up the hierarchy from it. So I'm passing in a photo post to a post variable. I'm passing in a message post to a post variable. This means if we were to add more posts, which I won't do in BlueJ, that our array list of posts can be message post, photo post, message post, message post, photo post. It's just whatever type happens to be there will be inserted at that time. Now, the reason this is possible is because the variables, the object variables inside of Java, are polymorphic. That is, they can hold objects of more than one type. Now, they have to be defined to be of the type in that inheritance hierarchy, but it can hold objects of the declared type or of any subtypes of that declared type. The thing is, if we have an instance where a subclass is being held by a variable farther up, a variable of a type farther up the inheritance hierarchy, how can we get back at the information that's inside of that variable? We can only go up the hierarchy. Okay, so if we come back to the idea, and give me just a moment, I want to bring this image, if I can, back over to this discussion. Remembering that the car is a vehicle and a bicycle is a vehicle. We can assign car to vehicle because it knows that. We cannot assign vehicle to car. Now, there might be times where we want to even need to do this. If I put a car object into a vehicle variable, and I know that that object is in fact a car, even though it's being held in vehicle, how do I get that to come back down to get the access to the pieces that are specific to car? Well, if we just try to do that directly, the compiler will yell at us and say that there will be the potential for lost information, and it won't allow the assignment of a vehicle variable into an object of type car. But we can use typecasting to allow for this. Yes, we know that you are a vehicle initially, but I know that I stored a car object in you, so I want you to treat yourself as if you are a car, and then I can store that reference back down into a variable of type car. And this will work, the compiler will allow it, but only if it actually is a car object. If it's not a car object and when you try to make this assignment, there will be a runtime error, your program will halt, and it won't be able to proceed. Okay, so how do we cast objects? You put parentheses and then an object type in the parentheses. And this is how we overcome that type loss, because once something's in a vehicle, is it a car? Is it a boat? Is it an 18-wheeler? Is it a box truck? Is it a scooter? We don't know. The object isn't changed. The object is still there. But when we try to do a cast, if we did not put the right object in there, if we cast incorrectly, a class cast exception gets thrown. And if you don't catch that exception, the program halts. Also, this is not like our best way of using superclasses and subclasses, so only use casting in very sparing ways. There are some use cases where it is unavoidable, but we're going to learn a couple of other ways to make use of inheritance that will not require explicit casting. Okay? When we come back, we'll wrap up this chapter by talking about the fact that everything you've been working with so far is extending a class automatically.